Okay, we're going to take a look at triangle review and just some notation today, because in our unit of trigonometry, we're going to need all of that to help us out. So it says here, triangles can be seen in a variety of situations within everyday objects. So trigonometry, the word itself, is going to talk about the study of the relationship between lengths and angles of a triangle. Okay, we're going to work specifically with those right angle triangles. And you know from previous study that those are the ones that have a 90-degree angle inside. Okay, when we go to label or name triangles, we often use letters to identify parts of those triangles. Side lengths, we're going to label with lowercase letters. Vertices, angles, all those sorts of things, we're going to label with capital letters. Or with the three letters that form the angle. So we're going to talk about that down below where I can give you a specific example. The hypotenuse, that's the word for the side length that's across from your 90-degree angle, and it is always going to be the longest side. Okay, in every right angle triangle, that will hold true. Okay, so just a quick example down below, you're just asked to label each triangle and each side length with upper and lowercase letters. So you can make any choice that you wish. I'm just going to stick with the most common three, A, B, and C. Okay, and again, our vertices or angles get those capital letters. Now, side lengths are always named for their angle opposite to them. Okay, a side length is built from how large that angle is. So for angle A, it basically dictates its opposite side length, lowercase a. Same pattern holds true for all of the other angles. So I'm actually going to change that color. We'll use purple. Okay, that'll be A. Side length B is going to be our hypotenuse since it's across from our 90-degree angle. And lastly, our side length C across from capital letter C. Okay, that's how we're going to label an angle, or a triangle, sorry. Now, when it said up above that we could label an angle using the three letters that form that angle, we could say, for example, I had angle A. Now, if there's a couple triangles, a bunch of extra lines, it's going to make it pretty complicated just to say angle A. That could basically relate to a few things. So if you use the three letters that relate to that angle, the way that it looks is you're going to start at one of the other letters. So let's say angle B. Okay, the letter that goes in the middle is going to be the angle in question that we're talking about. And the last letter is going to be where you end up. So imagine you take your pencil, you drop it right on point B, and you're going to trace out the direction of those three letters. So if you start at point B, you're going to travel all the way up to point A, and then down to point C to finish this off. Okay, those two red lines, those two rays, essentially form an angle in that triangle, which was the angle in question, angle A. And you could do that same process for any of those three angles in that triangle. Okay, underneath, we're asked to complete the following triangles by labeling those sides appropriately. So they've given us some information to work with already. So our goal is to fill in everything else that we don't know. So we have an angle of capital A, which means its opposite side needs to be lowercase a. We have a hypotenuse length of B, so its angle across from it needs to be capital letter B. The remaining side length, we were told, side length F, its angle needs to be capital letter F. And I think you could see the pattern as well, so you could complete the next two on your own, and the answer will be provided to you in the answer key in your Google Classroom post. Okay, onto the Pythagorean Theorem, which you have looked at before, not totally new. It gives you the relationship between side lengths and a hypotenuse. If you take the side lengths and you square them, add them together, it's equal to the length of the hypotenuse also squared. Okay, we're only going to do maybe just one of these, and I'll leave the other three for you for practice, because again, you're going to have the answers. So take a look at the first one here. Okay, determine the unknown side length. I've got a side length of 4, a side length of 8. Now both of those are legs. Okay, they're legs of that right angle triangle. Our goal is to figure out what the length of the hypotenuse is. That's the one that's missing. I know that's the hypotenuse since it's opposite my right angle. So if we use our Pythagorean theorem relationship, we could say that a squared plus b squared is equal to c squared. C squared is going to represent our hypotenuse. Okay, if we fill in some information, we have 4 squared plus 8 squared is equal to whatever our hypotenuse is squared. Okay, so 16 plus 64 is equal to our hypotenuse still squared. Okay, we're going to have to deal with that exponent in a minute here. So if I do 16 and 64, when you add them together, you get 80. That's equal to your hypotenuse squared. Now, if you square root both sides at this point, you're going to get rid of your exponents of 2. Okay, so the square root of 80 is approximately 8.9. I'm rounding this to the nearest tenth, and that's going to be equal to our hypotenuse. Okay, if you wanted to make this a little easier on yourself, you could just give that hypotenuse a letter. You could call it x if you wanted, and throughout your solution, you could use x instead of the word hypotenuse. Okay, and I'll leave the other ones for you. Sometimes just be careful. You might be given the hypotenuse, so just make sure you're using this relationship correctly. You may have to manipulate it as well. Okay. Okay, that relationship is going to be super helpful for us to determine a side length. The one thing it won't do for us in trigonometry is find an angle, so keep that in mind. Okay, one way to determine the degree of an angle is to recall one useful property from triangles, that the sum of the interior angles within the triangles is always equal to 180 degrees. Now what that really means is if you take all 3 angles inside and you add them together, they're going to add together to give you 180. So if you know 2 of the angles, you can always find the third one, which is exactly what we're going to do here. If I look at this triangle, triangle PQR, okay, we can use those 3 letters to name it as well. I know 2 of the angles. One of them is 90 degrees, represented by that box in the corner, so that's 90. The other angle is 45. I'm asked to find the missing angle. Now that missing angle can be written a couple ways. So we could call it angle P. We could also call it angle QP. That's not a P. QPR. We could also call it angle RPQ. Okay, just changing the direction of those 3 letters. All of those mean the same thing. So if we're trying to find that missing one, if we know all 3 of them should add to 180, we could take 180, which is the total, subtract 90 degrees, also subtract 45. The resulting number of degrees is going to give us that missing angle. Now, if you do that subtraction, you're going to end up with 45 degrees, and that's going to be for angle P. Okay, so that's the missing one. Same process is true for the other one, so you can give that one a shot, and again, you've got the answer waiting for you. Okay, next thing we'll touch on is reference angles. So the side of a right angle triangle can also be labeled in relationship to a specific angle. This is where we start to get into some of the concepts of trigonometry. Okay, the ratios that we're going to look at in this unit are all based on a specific reference angle. Okay, think of it as a point of view. Reference angle is the one you're considering for that question. Okay, so in trigonometry, there's 3 words that we're going to use pretty much all the time. Those words are opposite, adjacent, and hypotenuse. If you need a quick little reminder on what those are, opposite, you can think about being across from. I don't think that has 2 C's. Across from. Adjacent is next to or beside. And hypotenuse is your longest side. Okay. You do also have those down below, which will help you decide which one's which. Now the hypotenuse is going to be the easy one to find. Opposite and adjacent sometimes get confused, but with practice, you're going to be much better at them. Okay, so we're asked underneath to label each side as opposite, adjacent, and hypotenuse with respect to angle A. What that's really telling you is that angle A is the reference angle. Okay, that's the one we're going to use in this question. So if I take a look at the first triangle, angle A is the one that we're really concerned about. Okay, we're going to go label the other sides of the triangle. Now, I always start with the hypotenuse. Since I know I have a right angle, I know that this has to be by hypotenuse. Okay, it is that longest side across from that right angle. Now, the other two sides are the tricky ones. The one I always go to second is going to be my opposite side. So if I look at angle A, I can draw just a dotted arrow to the other side length. That's going to be the side length directly across from that. And that's the one we're going to call our opposite. The only remaining side length that we haven't dealt with has to be our adjacent. Okay, those are adjacent sides. So if we can label that triangle in the correct way with the words where they need to be, the trig ratios that we're going to learn a little bit later on, those are going to become much easier. So we're going to do all three of these because I know this is one thing that usually gets confused. So if I look at my second triangle, nothing's really different. It's just rotated a little bit. So again, start with your hypotenuse, find that right angle first, and there's our hypotenuse. Okay, angle A is the one we're using again. So here it is, circled in red. Now we'll do our opposite next. So find that side length that is directly across from that angle. That's going to be your opposite. The remaining side length, there's your adjacent. Okay, so you've got all three perfectly labeled. Okay, we'll do the last one as well. Again, start the same way, find that hypotenuse first. Even though the triangle's rotated, nothing here is different. Find your angle. Find the side length directly across from it. There's your opposite. Last remaining side length to deal with. There's your adjacent. Okay, we really need to make sure that we can label that triangle first, because if we can't, nothing else in this unit is going to work out for us. All right, one more here. Illustrate and determine the side lengths of and angles of a right isosceles triangle, triangle DEF, with a hypotenuse of 5 centimeters. Angle FDE is equal to 60 degrees, and the adjacent side is 3 centimeters. So they've given us a lot of information. So they've essentially given us the directions to create this triangle. Now, if you remember the word isosceles, that's going to tell us that two sides are equal in length. Okay, in a triangle, if you have sides that are equal in length, that also means the angles across from them have to be equal as well. Side lengths are built from their angles. Okay, so let's start out by just drawing a right angle triangle where we kind of looks like we've got two sides the same length. It'll be very hard to be exact here. I can cheat a little bit with the iPad. It makes some nice triangles for me. So here's my right angle. You could have drawn this triangle any orientation you wanted. It wouldn't make a difference. We're told our hypotenuse is 5 centimeters. So from wherever your right angle is, make sure your hypotenuse is labeled with 5 centimeters. I'm also told that one of my side lengths, the other ones, has to be 3 centimeters. Doesn't really matter which one you make it. Since this is an isosceles triangle, the other side length has to be 3 also. Okay, so let's try this out. I've got to label that triangle with its angle letters DEF. Now I'm told that angle FDE has to be 60. Okay, so make sure when you're putting your letters on here that you label them accordingly. So let's make the top one F, bottom one D, right angle will make E. Okay, so FDE means we're going to start at F, travel all the way down to point D, and over to point E. Those two red lines, those rays, create our angle of 60 degrees at angle D, just like we needed it to. All right. Now we're asked to go determine that other side length, and we'll see what we end up with. Okay, so based on the information we have, the Pythagorean theorem is the thing that's going to help us out here. So side length EF, if it's squared, that's going to be equal to our hypotenuse squared, so FD squared, minus one of our other side lengths, also squared, so ED squared. So if I fill in some numbers, we're going to end up with 5 squared minus 3 squared. Now EF squared, that'll give us 16. That means that EF is equal to 4. Now based on the angle given to us, it doesn't actually produce that isosceles triangle like we were told. Okay. Sometimes the angles in trigonometry, they're not totally exact, so just make sure that you're following the process exactly as we've done it here, because everything looks like it's where it's supposed to be. We might just need to have that angle fixed. Okay. We also need to go find that other angle, so we need to locate angle EFD. Okay, I know the other two angles, one of them is 90, the other one is 60. So that angle is going to be equal to taking 180 degrees and subtracting the other two. So I know I've got a right angle of 90. I know I have another angle of 60. So angle EFD in total is going to be 30 degrees. Okay, so we've found everything. So if you want, you can even label it on your picture. That was 4, and this angle inside is going to be 30. Okay, so just a little bit of triangle review before we really get into the stuff on trigonometry. So all the questions that I didn't do in there, you do have access to those answers if you would like to try them on your own. And we'll see you next week for the next video.